So in the previous class, we have discussed about different types of addressing, right? Basically, we have dealt with classful addressing. In classful addressing, we have seen different types of classes, and we have also considered like if some IP address is given, how to find the corresponding class. And also we have seen if an IP address is given, how to find the class and what is the range. Like you're going to have starting and ending address, right? Those are the details we have seen in the previous class. And in today's class, we will go with another topic which we call it as subnetting and supernetting. So what is this subnetting, supernetting? To get an idea about subnetting and supernetting, first we need to understand what are the problems we have with normal IP addresses. Like when we go with classful addresses, we said like if I consider class A, okay, each class A block is going to have 2 power 24 addresses, and each class B it is going to have 2 power 16 addresses, and each class C block it is going to have 2 power 8 addresses. So when I consider like this, if I consider any organization, I won't have this much requirement. Even I won't have this much requirement. But this number will be very, very small for that particular organization. So how are we going to meet the needs of an organization? That is the question. Okay. So whenever we have something like, if I have like this number of IP addresses available are less than our requirement, what I can do is maybe I can combine two such groups. Okay, two such groups I can combine and try to cater the needs of an organization. And if I have something like this, maybe I can divide into several groups and give for multiple organizations. Okay, so one thing is I can combine these IP addresses. That is one thing. Other one is divide the available IP addresses into different groups. So when I combine these things, we are going to say that one as supernetting. Okay. When I divide that available IP addresses into different blocks, I am going to call it as subnetting. Okay. I have a network. If I divide into smaller blocks or groups, I am going to name it as subnet. Network is divided into subnetworks. Okay. If I combine different networks to form a bigger network, like 2 power 9 you will have when I combine to 2 power 8, then that will be super network or supernet. The concept is supernetting and the resultant is supernet. Okay. About that one we will be saying, we will be looking like how to do subnetting, how to do supernetting, and we have considered, for example, if I consider class A, we have some default mask, right? What is the default mask for class A? 255.0.0.0, and for class B 255.00, class C 3255 and 0. So when I go with these things, like when I go with subnetting and supernetting, your mask is going to change. Okay, and we will consider here what is subnet mask, what is supernet mask. Okay, so those are the details we will be considering. So IP addresses are designed with 2 levels of hierarchy. Like whatever the levels we consider. What are the levels? Do you remember? Levels of IP addresses? Like out of 32 bits, how we are dividing? Default mask of A, we said like 255.0.0.0. How we are approaching with first byte 255? On what basis? You remember anything like network ID, host ID? Yes? So, the 2 levels we have are network ID, host ID. Okay? Whatever the masking we have, that masking we are getting from that only, right? So, like if I consider default mask of class A, we have 255.0.0.0. Why we are considering only 8 bits? Because the network ID consists of 8 bits. In class, similarly class B 16 bits how we are considering, because network ID consists of 16 bits. So when I consider original IP addresses, we are going to have like this. Okay, so a network with 2 levels of hierarchy, it can be considered like this. So I have entire network. This is my network address. which will be constant, like like in the routing tables, basically you are going to specify this value. Okay, it's like you won't say individual these things in a routing table. If I consider a routing table of any router, you are not going to say individual like 141.14.0.1, 0.2, 0.3. Like that, if I have to write, this routing table will have billions of entries, right? And if I have to look for some host, how much time we require? It will be very, very big. Instead, what we will do is we will refer the network address. Okay. So this entire network has some network address and individual host addresses. Okay. And what are the previous network I had? So this is basically class, which class? B. Okay, class B, because it is from 128 to 191. So how many such addresses we can have here? Like how many computers we can have? 2 power 16, that is 65,536. But out of this, one will be utilized for network address, one will be used for broadcast address. So I can say it is this one, 65,536 minus 2. That many number of computers I can have in this particular group. Okay. For better understanding, let us consider we have 2 power 16 different addresses. Okay. I am not saying how many we can give for computers, but we have 2 power 16 different varieties we have. Okay. That we want to make into 4 different groups. Okay, because I do not have any requirement from any organization which says like 65,536 addresses are required. So we are trying to make into smaller groups. Okay, so how many addresses you will have in each of these groups? We are dividing 2 power 16 into 4 groups. So divide by 4, that is 2 square. So you are going to have 2 power 14. Okay. So 2 power 14 means how much it will be? 16K. 2 power 10, we will call it as 1024 or we will represent with K, right? 1 kilo. So if I remove that 10, you are going to have 2 power 4. 2 power 4 is 16. 16K we can. Okay. And this 2 power 16, whatever we have, this is nothing but 64K. Right? 64K addresses are available and we are dividing with 4. So you are going to have 16K. So here I will have 16K, here I will have 16K. Okay, here I will have 16K and here I am going to have 16K addresses. Okay. So we will start from here. Like this is the starting address. Okay. And we have to divide into 4 groups. So this is the first group I have, and this is the second group I am making, this is the third group, and this is the fourth group. Now the question is from where I have to start and where I need to end. Okay. So the simplest thing, whenever we consider classful addressing, the simplest thing what we can do is, if I am making 4 different groups, okay. If I consider IP address like this, x dot, y dot, z dot, t, okay. If you are making 4 groups, you are going to have effects in this place. Okay. How I can say, like basically here I will have 256, here I will have 256, right? So you just divide this 256 with 4. What is the value I will get? 256 by 4, 64. Right. So second one will start at 64.0, 141.14.64.0. So this is the simplest way I am saying. Okay. So if I am just making 4 groups, okay, then I need to change this z value. If I have groups more than 256, then I need to consider t also. But I have only 4 groups, which is very much less than 256. So 256 by 4, then I will get like that. Then the next number, 64 plus 64, 128. Third one starts at 128. Fourth one starts at 190. Okay. I am saying this is starting, first one is starting at 0.0, second one is starting at 64, third one starting at 128, and fourth one starting is 192. So if that is the starting of second one, what will be the ending of previous one? 141.14.63.255. Okay. So that will be the last one here, and the last computer address, that will be 254, because that is a broadcast address, right? 255 is broadcast address. So the last computer will have this address. Similarly, here I am starting at 128.0. So the previous one will have 127.255 broadcast address, and the last computer address, it will be 141.14.127.254. Okay. So that is how I can get this address. Okay, that is one method. Okay, let me see if I have explanation of that. One 141.14, right? So 141.14.0.0. Okay, I'll show another way how I'll be getting the starting and ending addresses. So originally we had this many, 2 power 16. Okay. So for the original network, what is the last address? How I can find this? I have 2 power 16, right? Okay. So 16 once I need to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Original network, it had 16 bits per network ID, 16 bits per host ID. To get the last address, I need to consider how many bits we are considering per host ID. So how many bits we are considering? 16. So if I represent this one in dotted decimal, what will be this value? 255.255. So from this side, I need to add that value here. Okay. So obviously it will be like 0.0.255.255. Okay. So if I add to this, I'll be getting 141.14.255.255. This is the last address, right? For the original network. Okay. So like that I can calculate. Now let us try to calculate for this thing. Whatever the subnet we are doing. Okay. For subnet, how I can do? So see here, like 141.14.0.0, I have 2 power 16 addresses I had. But when I divide into smaller groups, how many you are going to have? When I divide into 4 groups, it will be 2 power 14. So now, how many ones I need to write? 14 ones, because I have 14 bits allocated for each host. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. From this side, 4, 4, and 4, and 2. So if I write data decimal, what will be the value? This one will be 255. Always remember, I need to write from that side, not from this side. Okay, whenever we are talking about last addresses. But when we are talking about mask, I need to write in this direction. Default mask or subnet mask, I need to talk in this direction. Okay, MSB to LSB. When we are talking about host addresses will be there from that side, right? So I need to talk from LSB to MSB. Okay, and what will be this value? 64. Okay, 64 or 63? 63, right? So 63.255. So I need to add 63.255 to this particular starting address. So I am going to have 141.14.63.255. So this is the starting, this is the ending of the first group. Second group, 141.14.64.0. And for this again I need to add 63.255. So if I add that one, it will be 141.14.127. 255. And again next one it will be like 141.14.128.0, like that it will be going. Okay, is it clear? Okay, so that's what we are doing here. So subnetting, basically dividing into smaller groups, and we are trying to find what is the starting address and what is the ending address. Okay. So this is like, originally I had an architecture like this, where I had two-level hierarchy, network ID and host ID. When I do subnetting or supernetting, I am going to have three-level hierarchy like this. Okay. So originally I had 16 bits for network ID and 16 bits for host ID. Whether we are increasing number of hosts or decreasing number of hosts when you do subnetting, decreasing. So where I need to reduce the number of bits? Host ID, right? So host ID I will be reducing. So these things it will be as it is, like this. Whatever the 16 bits I had, those 16 bits will be as it is. I need to consider extra bits here. How many extra bits we need? To identify entire network, we require 16 bits. How many extra groups we are getting now? 4 groups, right? 4 groups we are making. So if I have to represent 4 different varieties in binary, how many bits I need? 16. See, if I have only 2, like on and off, how I will be representing in the binary? 0, 1. Here we are saying 4 groups are there, 1, 2, 3, 4. How I will be representing? Can I represent something like that? 0, 0, 0, 0, 0, 1, something like that? Okay. Do I require the third one here? Do I require this third one? Not required, all are zeros, right? So in that case, can I say like I need 2 bits? First one I will refer with whatever 141.0, this thing will be as it is. Extra I am going to consider 2 more zeros. Okay. For the second one I will consider like this. For the third one I will consider like this. Fourth one I will consider like this. Right. Like that I can say. Okay. So how many number of extra bits we need? That depends on how many groups we are making. Okay. So the simple formula what we can use here is log n base 2. This is the formula we will be using. Okay. And what is this n? How many number of groups we are making? Okay. How many groups we are making? 4. So log 4 base 2, and the value will be 2. So I had 16 bits already, for which I need 2 more bits. How I am getting this one? By using this formula. So how many bits we are having in network ID now? Now network ID means, like you can consider this entire thing. 18. Okay. How many bits I have for host ID? 32 minus 18. That is 14 bits I am going to have for host. Okay. Is it clear? How we will be calculating subnet ID? Okay. Now the other thing we need to go is next thing what we need to consider is, earlier we had 141.14. How did we get? Because of 255.0.0 something like that. Right. Here by considering extra 2 bits, we are going to consider whether this is 192 or any other value. Like if you see the previous one, the starting address is 0.0. Here I have 64.0. Here I have 128. There I have 192. Okay. If I give any number in the middle, you should be able to find this one. Okay. Here also if I give any number, you should be able to find this one. Okay. How to find this? Like in the previous class we considered, right? If I give any IP address, you will be able to find what is the starting and last. Right. How you are finding? With class. Okay. With class also you can find, that is fine. But just consider that I just have some mask value. I don't know what is the class. In that case, you can use mask and IP address bitwise AND operation and you can find, right? Masking concept you remember, right? Okay, whatever the address I have, try to find the mask. Okay, use bitwise AND operation, you will get what is the starting address. Similarly, if I use that mask concept here, I should get this one. Okay, but what is the mask I have to use here? Is it 0? What is the mask we will be using here? No, we don't have anything like that. We had 3 different masks, 255, 000, like that, right? In this case, what we will be using? 255.255.0.0. Okay. So the problem is, if I go with that one, 255, 0, 0. What is the problem I will get is, whether I consider anything here, I will be getting the starting address. No problem. If I consider this one, I won't get this address, but I will be getting this address. Even if I consider anything here, I will be getting this, not that starting address. What is the problem? Why we are getting like that? That is divided into 4 groups. So I cannot use the default mask of class B now. Okay? I need to consider what is the one which I have to use for when I go with this subnet. Okay. So how many bits we are having in network ID for subnet? 18 bits. Earlier we had 16. So if I have 16 bits, this is the mask. If I have 18 bits, I'll get 2 more bits. Okay. So it will be like I'll have 1, 1, 0, 0, 0, 0, 0, 0. This is what I'll get in the third byte. So what will be this value? 128 plus 64. So my default mask now changes. Like I cannot say default mask, but for this subnet, the mask will change to 255.255.192.0. Is it clear? Okay. So when you do subnetting, you cannot go with the default subnet mask. But for this subnet, what is the mask I have? Subnet mask we call it as. I need to use that. Okay. So in this case, it is 192. Okay. Now again, you can verify here, like if I consider 255.255.192.0. If I do bitwise AND operation with any of the thing, I should get the corresponding starting address, right? Okay. So 192, like anyway, first 2 bytes as it is, I will be getting. That you are clear, right? Because I have 255, whatever the number, like whatever the number I consider in first 2 bytes, that will be coming as it is. Like if I have 141, I'll get 141. If I have 14, I'll get 14. If I have anything else, I'll be getting the same thing. So I'm clear with first 2 things. 141.14, that is clear. The next 2 bytes I need to consider now. What will be the starting address? Anyway, here I have 0. So the 4th byte also I will be getting 0. Now I have variation with respect to 3rd byte. 3rd byte 192 means how I can write? 1, 1, 0, 0, 0, 0, 0, 0. This is what I will have to write if I have 192. Now let us consider anything here. Like here I have till 63, right? Okay. Let us consider 141.14. Let us consider 63 itself. Okay. So if I consider 63, how I will be writing? 0, 0, 1, 1, 1, 1, 1, 1. So if I do bitwise AND operation, what I will get? All zeros. Right. So what is the starting address in that case? 141.14. Here I will get 0, 0. You consider 36. Okay, or 32. 32, let us consider. 32 means you are going to have like this. Sorry, all these things will be zeros. Okay, this is sorry. 32 means here you are going to have 1 and all zeros. Okay, in this case also you are going to get all zeros. That means even if I consider 32 also I am getting this one. Okay, now let us consider another one. Okay, so here we shall consider maybe some 92. Okay, or 96 we shall consider. 96 means how I can write 64 plus 30. So it will be like 0, 1, 1, 0. This is 96. Okay. And if I do bitwise AND operation, what I will get? 0, 1, 0, 0, 0, 0, 0, 0. So what is this value? 64. So did I get the starting address? Yes? Okay. Similarly, you consider something here. Maybe 128 you consider. Okay. If I consider 128, it will be like I'm going to have like this. 1 like this, right? And in this case also I am going to have 1 0. So I will get 128. If I consider something like maybe 160. 160 means how I will have 128 plus 32. 128 plus 32. There also 0 plus 1 you are going to have 0 each. Similarly here also you consider anything, you will get 192. Okay. So like that we can find the starting if you are given with a particular subnetwork address and if you are given with how many subnets are made. Okay, these are very, very important. Okay. So this is clear, right? With and without subnet, how your starting address is going to change. Okay, and starting address and also like you can find the subnet mask also by using this one. So this is something like we have hierarchy, area code I have, then exchange code and whatever the connection. In telecommunication we used to have like this, right? So similarly we have like subnet ID, like network ID, subnet ID, whatever the 2 or 3 bits we are using, then your host ID. Okay. So this is what we consider. Like this is the default mask I have. This was the IP address I used. So I am getting this as a starting address. But when you make subnetting, I cannot use this default mask, but I will be using this default mask. And when I apply that one on this one, I am getting another network address. That is what we have seen in previous slide. Okay. So what is the subnetwork address if the destination address is this one and the subnet mask is this one? Can you do this calculation? Right? So what is the entire final value? No, like subnetwork address. See, subnetwork address, when they say, that is the starting address. Okay. 245.32.56. Okay. So this is very simple. Like what we are doing is, we are considering this address we are considering in binary pattern. Then whatever the default mask I am considering in binary pattern. So till this part, entire thing will be replicated because I have all ones. Okay. Here also 4 ones are there. So 4 bits will be replicating as it is. Remaining position, whatever I have, I will be considering zeros. And if I convert back into dotted decimal, you are going to get like this. We will be getting 200.45.32.56. Okay. So if I have network, the starting address will be network address. If I have subnet, the starting address will be subnetwork address. Okay. Then default mask, like how we have come across that particular thing. If I am making 8 groups, I need to consider 3 extra bits. Okay. If I am making 4 groups, 2 extra. If I am making 16, you'll have 4 extra group, 4 extra bits. Okay, like that we will have. Then super network. Like, so I have first class C address, 256 addresses, second class C, 256, third class C, 256, and fourth class C, 256. So there is an organization which requires 1024 addresses. Okay, so how I can allocate? I cannot allocate from class B because it has 65,536. Out of 64K, if I just utilize 1K to give for this organization, 63K will be wasted. Okay. But if I go with class C, I have just 256 addresses. So what I can do is, I can combine 4 256 groups and form a super network. Okay. To form this super network, where I have to from the host addresses, I need to increase bits or decrease bits. For subnetting, what we did? We decrease number of host bits. For supernetting, we need to increase host bits because extra hosts are coming. Like earlier I had something, now that number is increasing. So I need to consider extra host bits here. Okay. In subnetting, we need the first address of the subnet and the subnet mask to define the range of addresses. Subnet, the first address we need, and subnet mask. Okay, without subnet, you won't be able to find what is the last address. Okay, in supernetting, we need the first address of the supernet and supernet mask. Supernet mask, it's like earlier 141.14 dot extra bits we have considered, right? Now we are going to reduce from here. Okay, to increase for host bits. Earlier, if I had 16 plus 16, and if I am making 4 groups combine to form a particular supernet, then it's like it will be like it will be 14, it will be 80. Okay, like that we will be making. Okay. So see here, like if I am making 8 groups, 3 more bits we are adding, and I will be getting subnet. If I am combining 8 groups to form single group, then we are reducing 3 bits and we will be getting this super network address. Okay, supernet subnet mask. Okay, is it clear? The idea of subnetting and supernetting of classful addressing is almost obsolete. What does it mean is, even though you go with this kind of things, we are not able to meet the requirements of the companies. Okay, because there may be some company which requires just 4 addresses. What you will do is that case, I cannot go with class C and divide into 16 such groups, right? Okay. So like that, some kind of complexity we are going to have. So that's the reason we are moving towards something called as classless addressing. Okay. So far we discussed about classful addressing, where we had class A, B, C, D, E, And we have seen like class ABC, network ID, host ID concept. Class D and E, we said like they are used for multicasting, and some class C is reserved for special purposes. And like what is the default mask we have, how to do subnetting, supernetting, what are the subnet masks, supernet masks, all those things we have seen. Now next we will look into classless addressing. And here we will try to understand the concept of classless addressing. What does it mean when I say classless addressing? Like earlier, if I look at some IP address, I'll be able to say which class that particular IP address. But when I go to classless addressing, we don't have any classes. Okay, each particular IP address is unique class. Okay, we'll be able to we will be able to understand how to find first and last IP addresses. Then we will be able to look at the concept of how to find network address. Network address means the starting address. Then again, we might be interested in creating subnet and supernet here. Okay, that concept. And we have special concepts like address allocation and address aggregation. These things we will be covering in classless addressing. So see here, when I go with classless addressing, basically you are going to have variable length blocks. When we consider classful addressing, we had fixed length blocks like 8 bits, 16 bits, 24 bits, like that we were allocating, right? Even if you are making subnet also, we did like each group has equal lengths. Okay, but when we go with this variable length blocks, when I consider class C, I can have one group having 128 addresses, another with 64, another with 32, another I can have 16, 16, 16, 16. Okay, does it make no? I can have just 2 16s. Okay, I might be interested in something like this. Okay, then I cannot go with classful addressing subnetting in such case, because I have variable length subnets here, right? But in the previous case, I had equal length or fixed length subnet blocks. Okay, so to go with this one, we are going with variable lengths. So you can see here, I can have something like this address space, something like this, or even just 1 bit. Okay, like that I can have variable length. So overall, when we go with this thing, I'm just looking if I have a diagram. Later I have. We'll go with examples. Which of the following can be the beginning of a block that contains 16 addresses? Okay. So to address this one, first we will see. Let us consider this address. Okay. Or maybe we shall consider something like 128.14.5.0. This is the starting address I have. If I need to give 2 devices, like if I want to allocate addresses for 2 devices, what I will do? I'll consider 5.1. Okay. Similarly, let me write first some addresses: 5.3, 5.4, 5.5. Okay. 5.6, 5.7. Okay. Similarly, I have 5.8, 5.9, 5.10, 11, 12, 13, 14, 15. Total 16 addresses I have. For example, if I am interested in giving only for, let us say, some 2 addresses. What are the IP addresses I will give? I will give these 2 things, right? Right. If I am interested in giving to 4 addresses, this entire thing I will give for 1 block, and this entire block I will give for another block. Okay. This entire thing I will give for another, and this combination I will give for another one. Okay. If I had 2, I was considering this as 1, this as 1. Okay. If I have 4, I am considering like this. So when I have two addresses, what is the starting address? What is the, like, when I look at the last byte, I have 0, then 2, then I have 4, then I have 6, then I'll have 8, then I'll have 10, 12, 14. Those are the starting addresses I will be having if I am giving for 2, 2, 2 like that. If I am giving for 4, 0, 4, 8, 12. If I have 8, I will give 0. 7 I won't give, 8 I will be giving, right? 8, then maybe 16, 24. So what do you understand with this pattern? So like with this knowledge, can you say whether any of these addresses can belongs to a block which contains 16 addresses? Starting it should be A, okay, A, then B, do you get 80 in 16 table? 16 5 times? 16 5 are 80. So can I consider that? C? Yes? Okay. Then what about this? 52? We won't get. So the possibilities are 32 and 80. So these two are it's just like some assumption. If these are the beginning addresses of some blocks, in this one I can have 30, like 16 addresses. In this one also I can have 16 addresses. Okay, but in those two I cannot have because we are dividing with 16 and we are checking. So that's what we are explaining. Now let us consider the next case. 256 addresses. Where I can have 256? Is there any option here which can be a part of 256 addresses? 32. Okay. Then that's it. So why 32? 256 we are saying, right? Not 16. Addresses I need to have 256 addresses. No one? Okay. So now let us consider. Maybe I'll consider 17.17.0.0. This is a class. Rather than that, I'll consider this class B address, which will be more clear for you. 193. Okay. Don't consider we are going with classes, but just for your understanding, I am going with this. Okay. If I consider class B, okay, and if I say like 256 groups, like I am making groups of 256. Okay. This is my starting address. What will be the next address? Like ending address? 190.16.255. I am saying only 256 addresses are there. I am making subnetting. How many addresses are there? 256. So what will be the last value? See, just some time back when we had two addresses, what was the last address? Here itself you consider two addresses means what will be the last one? 1. Okay, it will be like 0.1. If I have 4 addresses? 3. If I have 8 addresses? 7. So, can you get any last to find what is the last address by looking at number of addresses? Whatever the value I have, -1 and add here. So, what is the last address I get here in this case? 0.255. Okay. .255. What is the next block which I can have starting of next block? 190.16. Then what I am going to have next one? What is the next number after this? 0.256. Okay. Where it will end? 5, 510 or 511? What I have added here? 255. Can I add 254 here? We need to add 255, right? So what will be the value? 511. Okay. Then next. What is the next value? 512. That means you forgot complete concept of IP addresses. Can I have more than 256? Then how we are getting 256, 511, 512? That's it, right? If I like when we write these things in binary pattern, I have completed all ones, 8 ones I have completed. What will be the next number? I'll have 1 and all zeros. What is this value? 1.0. Right? Is it clear? Okay. So I am going to have here 1.0. What will be the ending of this? 1.255. Where next one will start? 2.0. So when I look at these starting things, if I have any block with 256 addresses, what is the last byte I have? 0. Do we have any addresses like that? We have, right? This is and this one. So if I keep on doing, at some point I will get 42.0. Okay. So in that case, can I say that is having 256 addresses? I can say, right? Similarly, here also at some point I will get 32. So I can also say we are going to have 256 addresses in this case also. Okay. So 256 means I won't have number there, but 0 you are going to have. Okay. Is it clear? 16 means last byte you divide with 16. If I have 64, last byte divide with 64, and you can say whether that is starting address or not. But if I have 256, you need to consider zeros. Okay. So that's what we are writing here. Okay. What's the time? Okay, we shall stop soon. So which of the following can be beginning address of a block which contains 1024 addresses? Now what I have to do? Can I divide with 1024 directly? No. Then what I should do? 1024 in dotted decimal, how I can represent? It's simple, like 1024 means 2 power how much? 10. 1 I will have, after that 9 zeros. Right? 2 power 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 2 power 10 position. Okay? 1 and total 10 zeros, not 9 zeros, because we have 2 power 0 also. So, these all 8 bits it will be 0, and these 2 it will be what? What is that value? 10 means. Sorry, 100 I need to consider. Because 0 to 7, the last byte, okay? 8 bits 0, and these 3 bits it will be 4.6. Right? 1024 means in writing 256 I can write 4.0. Or the other way, like 1024 is there. In binary I have to write what I will be doing? 2, 512, 0, again 2, 256, 0, again you will consider 2, 128, 0, like that you will be keeping on doing. But if I need radix 256, dotted decimal means radix 256. Okay? So 1024 will be doing with 256. 256 how many times? 4 times. What is the remainder? 0. Again 256, 0 times, remainder is 4. So I have 40. So I need to write 4.0. 1024. If I have to write in dotted decimal, I need to write 4.0. If I have 2048, 8.0. Okay. 4096, 16.0. Okay, like that you need to consider. Okay. So, like what is the value I write here? 1024 means 4.0, right? This is 4.0. So, can we say anything about which one will be possible here? 4.0 when I have last byte I need to have 0. Okay, like that I have two things. Second byte it should be divisible by 4. Okay, so 32 I have. Right? Is it clear? That's what we are doing. 1024, 4 into 256. So last byte we will have to have 0, and this side I need to have divisible by 4. Similarly, if I have 2048, okay, 2048 if I have, I'll be having 8.0, okay, and it should be divisible by 8. Okay, so like that we can consider. Okay, we shall stop here. Like we have just started classless addressing. We have seen how to identify the starting address. Okay, this is CIDR notation, classless interdomain routing. We will consider about this in next class. Okay.